Everybody, welcome to 2.06 Forces and Balance. So, today we're going to learn about forces in balance. A force. A force is a push or a pull exerted from one object on another. It has a direction and a magnitude, so it's a vector. The SI unit is Newton. As you can see, that guy's pushing that door, I guess, and that guy is pulling that door. I don't know why it's not opening and it's bending instead, but whatever. It's a push and that's a pull. Next let's look at some common forces: upthrust, tension, weight, friction, air resistance, and thrust. As you can see, that guy is trying to pull that box. Now the string has a bit of tension in it. That's a force. And as you can see, the box is pretty heavy. That's weight. And also, it has friction on the ground. That's another force. Now let's look at that jet over there. There's gravity, drag, thrust, and lift. Lift, we're just gonna ignore that for now. But drag is the friction between the air and the jet. Thrust is the jet pushing itself forward, and gravity is the weight. Now let's look at that boat. It's the upthrust of water and the weight of the boat. We've already looked at weight, but we haven't looked at upthrust. Upthrust happens when water pushes against something. It's like it makes it float. Anyways, Newton's first law. The first law states that an object at rest will stay at rest unless acted on by an outside force. An object moving will continue moving unless acted on by an outside force. In space, there is no air resistance, so an object will keep moving. Yeah. So what this means is that if you put a bottle on a table and you just put it there, it won't move, right? Yeah, exactly. Nothing will happen to it. So if you put an object in space and you don't do anything and you don't put any force on it, it'll just keep staying there. It won't float away or anything, it'll just stay there. Now this is what Newton's first law is all about. So imagine if you're in space and you fart a little bit. The fart pushes you forward. And then after that you just keep going. You just keep going and you won't stop. You'll be a rocket propelled by farts. This is pretty interesting because in space, the reason why you get propelled forward is because of the fart, and why you don't stop moving is because there is no air resistance to stop you. Or however, if you do this on Earth, you will most likely just get a couple of weird looks. Balance forces. If an object has several forces acted upon it, and they cancel each other out, but then the object will act as if there is no force acted on them. For example, this box over here. You push on either side, and you push equally on either side, so there's no acceleration. So for example, you get two equally sized men, and then you ask them to push each other. So they try and try, but they're both as strong as each other, so nothing happens. They just don't move. This is what balance forces is. They're in equilibrium and nothing happens. Terminal velocity. When a skydiver falls from a helicopter, his speed will increase over time, but eventually his acceleration will slow down and he'll be moving at a constant speed. This is called terminal velocity. Terminal velocity occurs due to the air resistance and her weight balances out, and his speed remains constant. So basically, it's like in the last unit where we drew a graph of a rock falling, right? It plateaus. That means that it keeps increasing and eventually it slows down. This is due to, as it said, air resistance balancing in with the weight. Air resistance increase over time because of the acceleration, the faster you're going, that means the more air resistance there is, and the more air resistance, the slower you go in. So when it balances out, it remains a constant speed. You're still going down, but at least you're going at a terminal velocity. Alright, that's the end. I just made it to 5 minutes. Thank you.